scotch. That's
That's
right.
recorded.
Oh wow.
No, we don't have this part of you. No, I don't problem, sir.
Oh, it looks like I froze for a second. Salut tout le monde. Nous là encore pour l'autre samedi. Nous avons un invité spécial, Johnny Boursiquot, Vladimir, JP, et Jean, nous connaissons tout le monde, nous avons un paquet de respect pour Vladimir. Vladimir et le Johnny, the legendary Johnny. So we're gonna not switch to anglais jeudi hein. Et pour nous pas besoin penser avec moi plus sinon juste parler de technologie hein. So Johnny is gonna actually show us how to actually do some cool stuff in Go, and I'll let the other guys introduce themselves real quick. We'll start with JP.
Yep, alright, okay. So, as always, comme toujours dit, I'm Johnny Van Spear, developer Capital by Dell. Focus on cloud native applications and so on. So, I think that's about it. And then I'll pass it on to Vladimir.
Bon, m'appelle en créole parce que I am in the Creole mental state. So, c'est Vladimir, comme nous toujours dit, nous fait chaque samedi. Jeudi, I'm dehors. I have some guests. Mais, je pense que parce que invité à tellement spécial que quand même, il faut là. So, Johnny Boursiquot, c'est un monde qui est vraiment bien regardé dans la communauté Tech Lab ici. Et moi-même avec nous croiser de temps en temps parce que la technologie que lui-même l'intègre la fait, c'est même technologie ça moi-même là dans tout c'est langue programming ça les Goa et c'est là m'a évolué, c'est là lui-même tout l'a évolué. So c'est un grand plaisir pour Johnny venir visiter nous aujourd'hui parce que lui-même c'est une vedette dans le monde Goa qui a fait des grandes merveilles. So tout le monde c'est Johnny Omandé, etc. So moi-même from de là tout. So anyway, ma passe la Johnny. He'll introduce himself.
Nice.
Hello, everybody. And merci beaucoup, Vladimir.
Yeah.
So you'll forgive me. We were just talking before we went live about how bad my Creole has gotten. Creole n'est pas bon, mes amis. So please forgive me as I sort of talk through all the stuff we're going to be talking about in English, not our native tongue, but we do what we have to do. So a little bit about me. I was born in Pétionville. And I've been in the States for going on 25 to 30 years now. So I've been around for quite some time, which is probably the reason because of my exposure to my Haitian community. It has gotten less and less over the years. Even my mother speaks English to me when I see her. So it's like I'm losing. I feel like I'm losing a little bit of my culture, my everything that makes me Haitian a little every year, right? So every year it takes more effort, right, to stay connected, right, to be part of the broader Haitian community. And when this opportunity came up, right, Rendell, we've been talking like since last year, right? We've been talking about, okay, when are we gonna do this? When are we gonna do this? And when the opportunity came up, really, it was something that really, it needed some attention from me, right? So I realized that, and we finally made the whole scheduling thing work. It's been a tough year for everybody. 2020 was, and maybe we're still seeing some of the remnants of 2020 into this year, but it took a lot out of us. But we got to keep our head up, right? So we got to keep doing what we need to do, keep surviving, keep thriving, and hopefully, this will definitely not be the one and only time I pop into this this channel. So my commitment is to really sort of re-engage more, right, to be part of this community a bit more, because I do notice it's gonna sneak up on you if you're not careful. You tend to lose your heritage around these parts in this country. So yeah, all that said, today we are going to be talking about some Go, the Go programming language, commonly referred to as Golang, because it's easier to Google Golang than it is to Google Go. You Google Go, you're gonna get all kinds of things, right? So Golang is what you typically gonna want to look for, and but the name of the programming language is Go. Vladimir also does a lot of Go, has written books on the subject, so he's gonna keep me honest as I go through this stuff.
I will try.
So yeah, so it's today what I really wanted to do. Actually, we changed. I think we might have changed the subject of this talk a number of times. Like I wanted to give a different talk around serverless and things like that, but there are so many moving parts to that world. I wanna sort of condense that material into something that can be sort of presented into a 45 minutes to an hour time block. So I reach for given that a lot of the folks in this community are going to be exposed to Go for the first time, or basically you're not immersed into it, sort of a day-to-day basis. So hopefully this will be, if it's the first time you're seeing Go, hopefully it'll be educational, kind of give you a sense of what Go can do. And if you've been playing around a little bit, we are going to touch on a little bit of some of the advanced aspects of Go as well, with regards to concurrency and things like that. So there's going to be a little, something for everybody, right? So I'm going to ease you into the world of Go. You're going to basically see the syntax, see basically some simple things that you can do with it. And then as we sort of go through our solution, we're going to add a bit more complexity, right? So, if you are familiar with Go, you're going to see something a bit more advanced. So there should be a little something for everybody. So
Johnny,
mm-hmm.
I was going to say, before you start,
Mm-hmm.
because usually in this forum, we're usually, it's intermediate to advanced. So can you tell the people why Go, period? You know what I mean? I mean, I could do it, but if you want to do it, I'll let you do it.
No, actually, this sounds good to me. So why don't you give a quick intro, right, to sort of why you would pick Go for certain things, right? And that way it's going to be sort of I can come back and sort of pick up from where you leave off. So why don't you go ahead and set us up?
Oh, absolutely. So, non, comme moi, créole m'a pas tellement malo, I'll do it in Creole. So, Go c'est un langage qui kounye kap mene, c'est-à-dire c'est ou gen Python, ou gen Ruby, qui est encore, ou gen JavaScript, ou gen Rust, JavaScript on the server backend, qui est encore Node. So tout langage ça son paquet langage qui dehors que entreprise yo toujours utilisé pour construire ça les back-end. Et Go c'est un langage ça yo. Et Go Go j'entendais ça c'est li écrit GO. C'est Go son langage qui sorti dans Unbounded compagnie les Google. Et c'est un langage qui plus récent, c'est-à-dire son langage qui sorti en 2009. So c'est un langage qui et puis nous gain Java tout, faut ne pas oublier Java. So comme on dit c'est un langage qui récent et c'est un langage qui mené parce que ça market là remarqué c'est que Go c'est un langage qui bon pour créer ça relais microservice or so si que nous convient dans émission nous convient dans les samedis nous content de parler de ça les microservices so Go c'est un langage qui est très bien placé pour créer ça les microservices c'est une raison pour laquelle que Go très très populaire parce que c'est un langage qui aide vraiment lorsque on crée ça les back-end soit créer programme pour centre de données yo, sous data center yo, c'est langage qui était créé vraiment pour fonctionner dans l'environnement ça yo. C'est ça que fait jodi a moi-même comme tu mentionné Go dans le passé, mais je vais retourner sur ligne, c'est pas parce que Go c'est pas un bon langage, mais c'est parce que Go c'est un langage bon, ou te gen droit premier langage ou, mais gen l'autre langage qui pi on plus facile. So c'est-à-dire moi-même, c'est m'dap commencer avec Node avec JavaScript et puis après ça m'dap prend Go. Gen moun tou qui commençait avec Python. Après ça, yo transféré ça yo apprendre dans Go. Gen moun qui commençait avec Java, comme c'est une nan ba m'de fait, m'de commencer avec Java, après ça moi changer pour Go. C'est ça m'de besoin, c'est une point m'de besoin faire, c'est pour qui ça que nous-mêmes n'a parlé de Go dans jodia, mais bien que nous-mêmes nous pas parler en pile de Go, ça va veut dire Go par un langage populaire. Go c'est un langage très très populaire. En pile dans toute Go compagnie yo utilisé et il y a des problèmes que l'on a résoudre, c'est Go qui comme c'est qui plus facile pour utiliser pour résoudre. Surtout si problème ça c'est l'on a implémenter des solutions qui mando pour créer des web services ou bien microservice architecture. So c'est point ça me développer.
Awesome.
That's good.
Yep, that's hits the nail on the head. Go has also been called sort of the language of the cloud for a number of years now. It's for that reason. It is because it is so widely used for building sort of a cloud native solutions, right? It was created at Google to solve Google scale problems. But obviously, the language is open source, so everybody gets to sort of participate in sort of the shepherding of the language. Although the folks who do sort of make the final decisions on what features make it into the language or what the direction the language is taking, that sort of the final say sort of rests in the hands of people who do work at Google. But that's not always sort of true, right? There are community members that are part of that sort of that committee, if you will, that influence the direction of Go. So one of the things that really has attracted me to Go, and I've been in the industry for 22 years now, so I've been in tech for a long time, and I'm really grateful to sort of have been around this industry for this long and have seen a lot of things come and go. I've seen a lot of languages sort of popular one year and not so popular next year for whatever reason, right? But Go, really what it has sort of offered me from a productivity standpoint, right? So when I sit down to write Go code, it's not as expressive a language as say something like Ruby or Python, right? There's usually just one or two ways of doing things in Go, not like 5 or 6 or 7 ways like you might find say something like Ruby or Python or JavaScript or something like that, right? Because of that, personally, I think that constraint of the language and the key, there's really literally like 25 keywords in the language, right? 25 keywords, right? Things when you're writing syntax for Go, it's a handful of words you can actually use to actually write Go code. So that alone already gives you an idea of how small and compact sort of the language is. And because of that lack of expressiveness, you might be thinking, well, like I'm a programmer, I wanna sort of use a language that allows me to express myself in all kinds of different ways and express your intent in all kinds of different ways. If you think about it, that can be sort of a double-edged sword, right? So I know many of us have gone into a code base, whether it be like a legacy code base or something you're working on with other teammates, with languages where they give you a lot of different ways to do things, a lot of clever ways to do things. And we can sit down and see a piece of code that says, oh yeah, this code was written by John, this code was written by Frederic, this code was written by Joanna. Like you can tell who was Joanna was writing this, because there's a different style that sort of pops up or surfaces, right, depending on who's writing the code, because there's so many ways of expressing the same thing in those languages, right? With Go, you have a little bit less of that, right? Even the formatting and how the code sort of flows on the page, we have tools that sort of normalizes that, right? So we have sort of ways, or what we call idiomatic Go within the community, ways that we expect Go to be written, right? That way, if regardless of the project you're sort of jumping into, that Go code is going to look very familiar already, or rather that you're going to be able to sort of read that code and kind of even if you're not familiar with the domain, the problem that code is solving, you're going to be able to read that code, that Go code itself, and kind of see what it's doing, right? So there's a bit of what you lose in terms of expressiveness, or all the different ways you can actually do something in Go. What you gain in exchange is sort of this constraint is sort of understanding, more readability, right? More simplicity in how basically what you're reading, right? It's sort of that simplicity sort of shines through. You can kind of quickly see what's going on in the code, right? So it's a trade-off, right? So if you love expressive languages like Ruby, or I haven't done a ton of Rust, but Rust arguably is more expressive, right? A few different ways you can do things in Rust, as opposed to Go. So these things are things you're gonna sort of balance in your mind, right? Which is more important to you, like the readability or simplicity of the language, or the expressiveness, or the different ways you can do something, right? So these are things that sort of are part of your decision, and when you're thinking about adopting a language, and obviously how popular the language is going to factor into that. Can you get paid doing things? At the end of the day, we don't work for free, right? We need to get paid. So basically, all these things are going to factor into your choice of the language. But like, I've been doing Go for at least 5 years now, straight. I can't remember the last the year I started doing Go, but I mean, Go has paid my bills quite well. So it was a good decision. It was a good bet to make, right? So yeah, so it was a good bet, right? So,
yes, it was.
So it's one of those things where again, that's kind of a lesson for all of us, right? As technologists, right? You keep your eye, as to what's going on. You keep your ear to the ground, see what the next thing is. Like, I mean, make no mistake, at some point, maybe it's 5 years from now, 10 years from now, Go is not going to be the new hotness anymore. It's going to be some other thing, right? So, we as technologists, we're paid to solve problems, right? Not really to write a language, or what. We wouldn't have to be fanatics about it. I mean, I love Go, and I love evangelizing Go, but at the end of the day, right, I have a family, I gotta feed them. So if something else comes along that is, say better than Go, or more popular than Go, whatever it is, I'm not gonna say, oh yeah, I'm not doing that. I want to stick with Go, kind of thing, right? There's a lot of things you can learn from each technology that you use, and Go's not the only thing I do. I'm an SRE, I'm a site reliability engineer, so I touch a lot of different technologies, on a day-to-day basis. So it just so happens that Go is one of my favorites, and really that's what I want to sort of show you what you can do with Go today through the stuff we're going to be talking about. So as we go, absolutely, the folks in the channel, as we go, I anticipate, questions as I go through some code. Definitely don't jump in, and I'll sort of explain things, especially, as I show the syntax, I'm going to sort of walk through it kind of slowly, kind of give everybody sort of digest it, and ask questions. And then what we're going to be doing is actually, we're going to be a port scanner. So if you're into security at all, or really if you've ever launched like a server in whatever language, right, be it Node or C# or Ruby, whatever it is, typically when you run a process, right, that's going to talk HTTP, right, typically you're going to want to listen, right, over a port, right? You're going to say, hey, this process is running on my machine. I want to be listening on the port, so and so, right? When you launch your database server, like locally, right? If you're on, if you're on Postgres, for example, by default, Postgres is going to listen for connections on port 5432, right? So that means when your client, right, the code that you're writing to actually connect to that database server, when you basically say, okay, well, I want to talk to this database server because I want to query to get data out. I want to, do inserts and updates, right, to push data in, to push changes in, right? You are making a connection over a port, right, to that server, right? But whether it be local or remote, right, you are talking over a port, right? Because the operating system, the system that's going to actually receive that incoming request from the client, it's going to actually bind that connection request, right, to the port of the service that is behind that particular port, right? So when we talk about port scanning, we're really basically saying, okay, well, given a system, given a computer, right, whether it be local or remote, can I get a list of all the ports that's open on this particular system, right? So your scanning, right, is basically saying, hey, is port 8080 open? Yes or no? Is port 8081 open? Is port 8082 open? So on and so forth, right? So that's what we mean by port scanning. So before I sort of dive into code, what I really want to do is actually show you. Let me launch my. Share my screen. Yep.
Yeah, just before you do that, I was gonna actually ask you a question, especially because you mentioned
please. Yeah, do it.
But Fiji Mix actually just showed up. I'll let him see what's up before I ask my question.
Hey, what's happening, man?
Well, we're glad to have you on board, man. I believe this is the first time that we have you on, and I'm starting here a lot of good stuff about Go, which I'm really interested into. Again, I think as we are technologists, we're always looking for the hard things. Of course, Go is not the hard thing right now, but it's definitely a powerful language that we can all learn from. So I'm really excited to be here. And again, feel free to ping me any questions. I'm listening, following. And if I have any commentary, I'll definitely add them on.
Sweet, awesome,
cool. Yeah. So my question actually is, I'm guessing you're already looking at Rust, so you have an impression of Rust, and all your experiences with Go. My team. Well, I forgot to actually mention that in the beginning. I'm a software engineer with Cox Communications. So we mostly focus on data collection, things about the network. We're doing, SNMP and, BGP stuff and collecting data mostly. So now we're not exactly writing system software. System services.
Go.
So, yeah.
You just answer your question right there, man.
No, I got you. Yeah, because we definitely not messing with a lot of things that, but we also like all the bells and whistles from Russ regarding the fact that you can't mess up with the pointers and all this other stuff, the borrowing system and stuff like that. But I guess I'll stop here. Go is the answer. I know if I ask Vlad, but you can give me your impression. Yeah,
so I'll take a first crack at it, and I'll let Johnny finish. But so you actually answered the question. So if you're not doing any kind of system level programming, although Rust, to be fair, can do more than just system level, I think Go would be a perfect language. So if you're coming from any of these languages, like your Python, your Ruby, your Java, I think Go is a progression that makes sense, especially if you want to get into things like concurrency, better memory management of your of memory resources, et cetera, et cetera. I think Go makes sense. Now, I would never tell somebody not to look at Rust because, hey, it is the new shiny thing. Go and look at it, but be ready for the learning curve. But Rust has its place. It is a more of a system, and when I say system, I do mean system. Like, for instance, a lot of people are using Rust to write kernel level type tool using Rust, and a lot of people from the C++ world are looking at Rust because of that. But if you're more in the microservice back-end data center, regular service architecture, I think Go is one of the ways to go. Not just because that's what I do on a day-to-day, but because it gets the job done and get out of your way quickly. So right. I'll let Johnny finish up.
Yeah, I mean Vladimir hit the nail on the head. It's so my caution to you, and I exercise the same caution even when I was looking into Go. Basically, it at some point you're gonna look at the language and evaluate its technical merits, right? Like how good, right, is this language, and you're always gonna have sort of something that you're comparing it to, right? So we love to compare one language to another. To say, well, what can I do with this language, or what can I do something in this language over this other language or these other languages? What appealed to me specifically about Go was the fact that it was simpler, right, yet more powerful than a lot of other languages on the market, right? So that's a very hard balance. That's a very hard thing to achieve from a technical standpoint, right? The designers of the language, they were deliberate, right, and basically say, hey, we want something. We don't want to write C code, right? It takes too long to compile, right? We don't want to do C++. That language, when you're trying to do more complicated things, can be a mess to deal with, right? What's the happy medium, right? What can we get from each of these sort of low-level languages that we're used to working with, right? And what can we get from these things, and then fix the things that we don't like about those other languages, right? The long compile times, the complicated approach to to structuring your code and all that stuff, right? What are the best qualities we can pick from these languages, right? To create something new that addresses these existing challenges, yet is more powerful than those things in a lot of ways, right? So today, if you're writing very, very low-level code and you need kernel access, I'd say look at C, right? Still very good for that stuff. Look at C++ if you must. And look at Rust, right? I'd say those are the things you want to go to. If you're writing operating system level stuff, and like Vladimir mentioned, like kernel level stuff, that is the sweet spot of those languages, right? You can do some of those things with Go, right? But perhaps it won't shine as bright as some of those things. And in some cases, C is going to be faster than Go. In some cases, Rust is going to be faster than Go, right? For certain things, right? So, but if your line of work, right, is not in writing, kernel level code, not in writing operating systems or things of that nature, right? And if you're sort of where you are in your line of work, right, is writing sort of integration code, getting systems to talk to each other over a network, right? Getting systems like cloud native systems talking to each other, building queuing systems or building sort of a networked software, right? Really, in my opinion, there is no better tool today than the Go programming language, and that has been so for the last 5 years. Go is called the cloud native language for a reason, right? So Go, like if you look at the cloud native foundation and the list of software, virtually all the projects in the cloud native foundation's list of things that are either incubating or that have graduated, the vast majority of them are written in Go. There's a reason for that, right? So that's what stuff I'm saying. Like when you're trying to pick your next language in your career, like yes, you might evaluate the Go language and say, oh, Go doesn't have generics. That sucks. Like I'm a programming language nerd, and I really want to be able to use generics to do certain things, right? Well, yes, that's the technical aspect of your evaluation of the language. But if I look at the cloud native foundation and looking at all the software that's being built, I'm thinking, okay, if I want to use these tools, like what is the surface area where I'm going to get paid, right, to write the language for all this software, all these things that people that they're building. People like us need to actually operate these things. We need to run those things. We need to tweak those things. So when I look at the CNCF and look at all the software, I see these things. I see dollar signs, and I'm like, okay, these are opportunities, right? These are if companies adopt these pieces of software, like these are opportunities for me. Like they need people to run these things. They need people to operate these things. Like universities aren't teaching this stuff in school. Like I mean, schools are like so far behind. Like there's no school teaching this stuff.
Who is this?
Teaser code. Je vais parler de COBOL.
Get it massive like that. I'm back on now, man. This is not chat line.
What's up?
The live today is in English partially.
Non, ma bon créole là, mais pas un problème. Non, ma bon là. So, topic, c'est là, je suis jeune à discuter assez go. Et moi, je vais ajouter l'autre barre de go. Tout c'est que, moun qui apprennent go, pas jamais de problème pour joindre travail.
Yeah.
Right, Johnny?
Yeah.
I mean, none. Et
Yeah.
l'autre barre pour ajouter, tout c'est que, non seulement pas de problème pour joindre travail, mais niveau paiement que vous joignez, comme si on a dit, toujours plus haut que si c'est.
Yeah, on a pratiquement dans range 150 000, 200 000.
Même si on fait.
No, yo, regardez range salary, yo.
Yeah, no, so you're right. You're right. No, on devrait faire point ça parce que so Go c'est un langage qui est populaire. That's wonderful parce qu'on paquet de langage qui est populaire. Mais Go dans côté lié dans market là, c'est comme John était dit, c'est un langage que tout le monde le gon bail c'est de comme on a dit qui involve networking ou bien cloud native, tout bail ça le plus souvent c'est Go yo gardé et tout le monde presque tout Go comparé c'est ça a fait.
Docker, Kubernetes, tout bail ça written in Go.
Tout bail ça. So c'est ça me devait faire. Les petits points ça me devait ajouter c'est que soit apprendre Go aujourd'hui non un an ou après que Boussou a un petit gens plus bas, right? La plus lourd.
Okay, Anthony to Johnny, and so he can show us some codes and stuff.
Yes, sir. Yeah, c'est pas menti, no? Yeah, so let me quickly.
You I understand everything that you just said. So no worries. You can go on in English.
Awesome. Yeah, criar muito para bom, mon cher.
Bible.
All right, let me share my screen real quick. Let's see, share screen. And I'm going to pick screen 1, which hopefully.
Okay.
All right, so hopefully you should see a slideshow. Is that what you're seeing?
Yeah.
All right, cool. All right, so let's set up some basics here in order to sort of understand what we're about to write code for, right? So remember, this is a sort of a simple exercise in writing a port scanner, right? So the idea behind the port scanning is that you have a client and a server, right? So our client in this case is going to be, I'm on my laptop, I'm going to be writing code that is going to serve as a client that is going to try to communicate with a server, right? In this case, my laptop is also going to be the server I'm communicating with. But this code, there's nothing that stops it from talking to another server across the internet, right? The idea is that you have these two parties, right? And within basically these two entities within this relationship that basically we're trying to establish, right? So you have your client. The first thing your client's trying to do when it's trying to connect to a server, right, and to say, hey, is this port open, right? It's basically going to send a packet, right, a TCP. This is TCP communication. It's going to send a packet, a SYN packet, a synchronized packet, to the server. Okay. The server then has a choice to basically, if it chooses to respond, it can send what's called a SYN ACK. It's an acknowledgement of the synchronization packet that was sent by the client. Basically, say, yes, I received your synchronization packet, and here's an acknowledgement for that. Here's the indication that I did receive, and I'm willing to sort of continue the conversation with you.
Is it
at that
also
point
called heartbeat?
That could be interpreted in different ways depending on sort of what level of the stack you're at, right? So this is purely using sort of the terminology, right, for TCP-based communication, right? So if you say heartbeat here, that may be a little out of place, but I get what you're saying, but it might be a little out of place. Okay. So once you get that the acknowledgement from the server, the client then sends an acknowledgement, right, that it has received the original receipt, right? So it's kind of like saying basically, yep, I received your acknowledgement, right? So once it sends the acknowledgement back to the server then says, okay, then we're good to go, right? Our connection is established. You can then talk to me, right, on whatever port that you're trying to connect to. I will allow this communication to happen, right? That's basically this is where you establish the connection with the server and everything goes well. This is the happy path. This is when everything goes well, okay? There are cases where the client sends that synchronization packet, okay? The server, right, basically, if the server responds, may actually send a reset packet instead. That reset basically tells the client, negative. I don't really want to talk to you for whatever reason. Maybe it, there's some security boundaries. Maybe that whatever reason, may be, the server, is actually responding in this case, but it's actually saying, no, I really don't want to be talking to you right now, okay? For whatever reason. It could be that there's the port that the client is trying to connect to. Say I try to connect over port 8080. If the server doesn't have anything running that is bound to port 8080, on it, it may basically say, there's nothing there for you, right? So it may not even be like a security thing. It could be that basically you did get through the firewall, you did get to talk to the server, but you're trying to connect to something on a port. There's nothing there listening and responding to you, right? So the server is going to send back this RST packet back to you. So Go allows us to actually sort of facilitate this whole exchange, this whole communication. Go allows us to actually do this whole exchange without actually having to bring in additional software, additional libraries. All that stuff is part of the standard library package. So what I mean by standard library is that obviously when with any other language, you have people that are sort of writing libraries and packages and plugins, et cetera, within that community. But these things are you typically importing into your code to actually make use of that functionality. And the Go ecosystem is very rich, right, with that kind of contribution. There's lots and lots of packages, that are being contributed by Go developers every day. So it's a very rich ecosystem of functionality. But the Go language itself, when you install it, right, you get what's called a standard library that comes basically with the language. These are things that are these are libraries that are part of the your Go install, right, from the ground up, right? So you install Go and you get access to all these things. They come as part of your installation of Go. So you don't need to bring in anything different, anything new to actually be able to take advantage of certain things. The net package within the Go standard library, and there's lots and lots of packages within the Go standard library. The net package in particular offers functionality that we're going to leverage to actually do this whole dance, this back and forth, right, between the client and the server. The dial function within the net package, and we're going to see how this actually plays out in code. The dial function under the hood is actually going to facilitate all of this sort of interaction with us under the hood, and actually gives us a very simple mechanism to say, okay, I can assume my connection is established if nothing bad happens, or if something bad happens, then I can assume that I couldn't establish a connection for whatever reason. It could be that there was a firewall preventing the connection, so the server never even got the connection request, or maybe you tried to connect over a port and there's nothing running behind that port, right? For whatever reason that is. So the dial function is going to sort of give us a nice abstraction layer, right? Between sort of knowing whether that port is open or not, and we can actually leverage that in our code. All right. So now that we've taking a look at that, I'm going to tuck away those slides. This is the last time we're going to see slides. Let me now pop open our first example, this very simplest example that could possibly work for what we're trying to do. So let me zoom in a little bit. So if this is your first time seeing Go code, let me give you a minute to sort of take it in a little bit while I take a sip of my scotch.
So, juste en clarification, c'est que code n'a pas gardé, c'est pas un code que de jour, comme je l'ai dit, après on code comme ça chaque jour. Mais code ça, c'est un code fondamental qui est de Go fait ça le network programming. C'est-à-dire, on doit utiliser Go pour construire port server power bien facilement. On doit utiliser Go, comme Johnny pourra le montrer tout à l'heure, pour construire des outils pour ça le networking pour faire network pour network. So Go bon vini tout préparé avec des packages standards qui permettent de faire de type de programmation ça sans que ou pas besoin aller dans download au paquet bagay juste pour essayer de réaliser type de programmation ça. Et type de programmation ça, comme on dit, de jour à jour, c'est pas de programmation à faire quand même, parce que si c'est dans le monde front-end long, c'est pas de type de programmation à faire. Si c'est dans le monde back-end, ou pas vraiment nécessaire à faire type de programmation ça, mais get des jobs, get des responsabilités de si c'est ou même qui cap fait ou takou ça John était dit si c'est SRE takou monde qui responsable pour manager ça les computers ou bien banque de données etc. Ça c'est type de programmation ça va faire et faut comprendre network là, faut comprendre qui pour manœuvrer network là et faut qu'a faire écrire des codes pour aider faire ça les automations pour network là et c'est et type de programmation ça que code n'a gardé à et de faire avec Go. So well quiet kunya.
Awesome. I like you should come to my talks, Vladimir. You know, you explain things so well. You translate from not just the English to Creole. You translate into the simpler terms. I mean, like if you've been doing this for a while, you forget like people don't always understand what you're talking about, right?
It was a nouvelle émission prof.
Awesome. All right, so the let's. We're looking at about 17 lines of Go code here. Let's quickly sort of walk through before I actually dive into. Let's talk about the whole port scanning thing. Let's actually do a quick sort of a look through each of the lines here, so you get an idea of what it's like to write Go code. Okay, so the first thing you need in every sort of file, right? In every Go file that basically you're gonna feed into the compiler, for it to sort of go through and figure out what it is that you're trying to do, is every file needs a package declaration, right? So other than comments, right, the very first piece of code that needs to be sort of interpreted, that needs to be found in your Go code, is a package declaration. So in this case here in line 1, I have this package main. So there's two kinds of programs you can build in Go, right? It's either what's called an executable, or what's called a library, right, or a package to be imported by an executable. Okay, so what I mean by that is that, like basically maybe you're writing a program that needs to sort of import a third-party dependency, right, that does something in particular. Maybe it's a package, it's a library that helps you with credit card billing, right? That's not something that comes with the standard library, right? So you may need to sort of import, find a third-party package, hopefully from a reputable source, and basically you grab that and you import that into your code, and then basically you're now using that package. So that package on its own can't be a program. You can't run it. It actually has to be imported into something that can then be turned into a program and run, but it uses this library, right? So library code cannot be executed, right? So what you can do, so the executable programs, the programs that we're writing here, basically they need sort of this package main and this, as I see on line 9, this function main. Those two things make your code an executable program. Okay, so what's a library package in this case? Well, let's look at the import block we have here from line 3 to all the way down to 7. So this import block here, we're importing 3 separate packages. We're importing Fmt package, more commonly referred to as the Fmt package within the Go community. You don't have to call it that. You can call it FMT if you want, but you sound more like a Go developer if you call it Fmt. Okay. We have the log package, and we have the net package, and we're gonna see the use of the net package pretty soon here. But the FMT package, as sort of the abbreviation implies, it can help you with some formatting, right, of output. So when you want to print something out, you can format how that printout sort of shows up on standard out on your screen. In the log package, like the name implies, we can do some logging output, right, using the log package. The net package is what contains the kind of functionality that we're going to be leveraging for our port scanner, and it is really part of the standard library. So typically, whenever you see those sort of a short, sort of a non-fully qualified, like no domain names in front of these sort of a package names and things like that, these are things that are coming from the standard library. Okay, so the packages that you import in from third parties, they typically will have sort of a full path in front of them, meaning that you might see github.com/somebody's name/some package name, right? Or you might see gitlab.com/somebody's name/some package name. So there's going to be sort of a full URL location, if you will, that you're going to be importing in, thereby allowing the Go toolchain, right, when you build your program or when you test it or whatever it is, for it to actually know, where do I go on the internet, where do I go retrieve this code that you're actually referencing in your Go code, right? So we don't have any of that in this particular code. Again, we're using all standard library functionality for what we need to do here, but basically that's one thing you can do that I wanted to sort of bring to your attention. Like, basically you can bring third-party packages. They'll just look different when you actually import them here. They won't be as short, they'll have a full domain name as part of the name of the import. Okay, so but again, importing, this is you can't use functionality from a package without actually importing it, which is why you need this import statement here. And basically I've just grouped all the imports that I'm doing here. I could do one by one. I could do import Fmt, import log, import net, but the shorthand here is basically say, using the parentheses, I can import multiple packages and just have one import statement. Okay, so hopefully that makes sense so far. We've looked at what package, that we know that we need package declaration on top of every file. And we know that, to make use of a particular library, we actually need to import it. Go will not let you compile code, right, if you import a package that you do not use. Go will yell at you and says, hey, you're not allowed to, you imported a package you didn't use. You can't keep it in there, right? So you have to take it out, right? Same thing for variable declarations. If you declare a variable and you don't use it, Go will not let you compile the code, okay? It'll kind of yell at you. So it kind of forces you to be clean. It kind of forces you to look after yourself, right, a little bit. Don't leave things in there. And you can get around that by commenting things out, right? But, again, you're kind of going around, if you know you're going to come back to a piece of code, it's fine to comment it out. But typically in my day-to-day, I don't sort of open pull requests, or I don't try to merge code in that has a bunch of code commented out. That, to me, that's basically, this is unfinished work. So I'll just keep that out of a pull request, right? But the idea is that, Go will not let you basically, put things in there as basically interpreted code. It will not let you sort of keep things in there that you're not actually using. Okay. Yes.
So I was just gonna add. So si que ou utiliser un autre langage takou Node ou bien even Python, so concept package là c'est même nan, c'est-à-dire ou gen en librairie quelque part qui gon fonctionnalité quelque part que ou ta remen intégrer dans programme, et ou si c'est npm ou bien ma songe l'autre package manager, but ou ap utiliser package manager pour intégrer l'autre package dans programme. Et c'est même pas avec Go. Go is exactly the same thing. So Go gain même concept là. Si que ou gon une fonctionnalité quelque part, c'est son l'autre monde qui écrit fonctionnalité là, et fonctionnalité là li nan on package que ou même ou pas c'est pas ou mettre li. So for importer package là dans programme. So dans code n'a regardé ya, code ça c'est package non package nou yo, package a vini directement avec Go, ou pas besoin de l'autre côté de pour download Go, yo là. Yo bon ou ka utiliser yo. Mais comme Johnny t'a dit, si que gen des fonctionnalités, gen ba ou vle qui pas nécessairement fait partie de Go, so kounya là ou pral obligé importer package. So that's all I wanted to point out, that other language have basically the same thing.
Sweet. Awesome. So now we're about to jump into sort of the meat, right, of our code here. So I'm going to sort of jump around a little bit, and I'll call out the lines that I'm on as we go through. So remember, we want to use the dial functionality, right, of the net package. Okay, so the think of sort of this dial function, right, as one of the pieces of functionality that the net package actually exposes. So the dial function is only one of many other pieces of functionality that the net package exposes. So if you want to know, well, how do I get a list of all of them, right? So let me quickly now show you. If we go to go.pkg.dev, pkg. Is it pkg.dev? What's going on?
I thought it was pkg.go.
PK, is it?
Maybe I'm wrong.
pkg.go.dev.
There you go.
All right, I always have to look it up every time. All right, so here we go. So let's go to the root of this. Actually, we could, I should have started out at go.dev. So, oh, by the way, this is actually a good segue. If you want to learn more sort of about Go, so find tutorials and things like that, this is a good starting point. If you go to go.dev, that'll be a sort of a very good starting point for sort of the kinds of resources you can check out. There's some blogs and online materials and repositories, all kinds of goodies. You can definitely start here to sort of as sort of your starting point for learning Go. So on there's this nice little sort of a search bar here, or you can also go click the discover. Whoops. You can also hit that the discover packages link, and that's going to take you to this search screen here. So if I search for the net package, all right, one of the first results going to come in is this, the net package, right? And obviously you're going to see that a lot of other things in the net package. And here's what I meant by the third-party packages that are not part of the standard library. When you install Go, they're not there already. You need to import them in and sort of pull them from the internet. You're going to see things like this, for example. This is going.org/x/net/context, right? You might have to pull that in if you want to use the functionality from that package. And there's going to be other ones as well. So if you wanted, and I'm just showing for the net package here, so you wanted to say, I think credit card was one of the examples I sort of referred to. So there's lots of packages out there, right, that do something about credit cards, right? So if you want to know, is there a package out there that offers functionality that I'm about to build? So I'm a big fan of not having to reinvent the wheel if I don't have to, right? So usually what I do is, if I know there's a piece of functionality, a concrete functionality that I need, that I suspect might already be out there, right? I'll come in here and do a quick search and see what comes up, and see, if I can find something from a reputable source, maybe from a well-known company, well-known brand. It's something that I have some high degree of certainty that if I import this code into my project, they're not going to start to backdoor stuff into some other, send information to somebody else, behind my back kind of thing, right? So I'll come in here and do a quick search, right? So when I need to use these, so if I just grab this first link, for example, typically, right, when you want to use this stuff, and they usually have examples. Does this one have example? This one doesn't have examples. So this is an example of a poor README for a package. So
They have a list of sections.
yeah, so that's great. Let's see if we can find something different here. Usually they have examples. Yeah, another one that has poor.
I was
Go ahead.
No, I was going to say the standard library has examples, so we probably could jump there.
So for example, right, this is the HTTP, the net HTTP package, right? You can actually see, they actually show you exactly how to use it, right? So a lot of times when you're searching around for a package that does something that you need, right, the well-documented packages will actually have examples of how to actually use the functionality, use the behavior of this particular package, right? So let's go back to the net package here. That's it. Oh, and by the way, let's go back here. So you see, you have the net package, and then under the net package, you have a /HTTP, and then there's a net URL, and so on and so forth, in net HTTP prof. don't call those, you know, HTTP or something like that. Don't call these sub packages. That's not a thing in Go, right? That's just a package path, right?
Bro,
Don't
that's exactly what I thought myself. I was like, what the heck? What was
yeah.
package?
Yeah, don't assume there's some sort of like, you know, like inheritance going on, that if you import the HTTP package, you know, you get everything from that. That's not a thing, right? That's just a package path. So typically there's going to be functionality that exists as one that is referred to, you know, from what you'd call quote unquote the parent package, but really this is just a grouping mechanism, not necessarily sort of a parent-child relationship and like a strict, you know, sort of a hierarchy, right? So just a quick sort of side note there. So let's look at the net package. And if we, on the left-hand side here, I'm going to hit the index. That's going to take us down to the list of all the sort of the types and functions and things like that we can actually call on, right? So as you see here, there's a long list of types and functions that we can call on. So let's find the dial one. Let's do a quick search here. Where is...
There you go.
Dial. There you go. So you have this dial function here, right? Which basically says, let me take out the highlight here. This dial function basically gives you some information around what are the capabilities. And let me zoom in a little bit to make it a little easier to read here. It kind of gives you sort of a, this is what the function does. These are the parameters that you need to worry about. This is the stuff you need to send in. So in our case here, we know that we need to send in sort of some kind of network type, right? So your options, you know, as listed here, range from simple TCP to you being basically very explicit about, okay, what version of TCP am I using? Am I using IPv4? Am I using IPv6? You know, is this a UDP network? Like, what kind of network am I talking to? Is this like you have options, right? Basically, this covers the really all the different network types that you might want to interact with, right? Basically, you're gonna have to specify this a string value, right, for the kind of network that you wanna talk over, and then you're gonna have an address. That address basically is gonna be, as the name implies, what is the location that you're trying to connect to. Okay, like you know, in our case, it's going to be a local, like a local host, right? 127.0.0.1, or local host, the word, you know, basically it's all like the loopback address. But if you have an external remote service, maybe you could hit google.com, or maybe you could hit the IP address for some known server to you, whatever the case may be, right? You are going to be connecting over that network. Using that address, you are going to connect to that particular IP address or host name, and you're going to need the port that you actually want to connect over. So you can't leave that out. So if you have basically you see that all the examples here that are provided, you have the address, right, the IP address here, followed by a colon, followed by a port. Right, you always need that port in there, right? So, for example, you can dial TCP, but well, other than an IP address, you can also have the host name, right? And you can have HTTP as sort of the port.
Alias.
Yeah, go ahead.
No, I say like an alias.
Right. So under the hood, that's just going to translate over port 80. Right, basically just connecting over to going.org, going over to port 80, right? So so that dial function, right, is just one of many, right? So if I go back here, so if you scroll down, you're gonna see a whole bunch of different things, right? So like in my 6 years of using Go, I haven't used half of these things yet. Like, you know, again, this is one of those things where it pays to have awareness of what functionality exists in a standard library, or really what functionality exists out there in general, and then sort of a when you face a problem, you're like, oh yeah, I remember this. I'm part of the standard library that does this, or oh yeah, I came across this package, you know, that does, and you go search for it, right? Like there's no way, and it's not feasible or practical to try and remember all these things, right? Like, you know, when I need something, I come look for it. The Google-driven development is a thing, right? So when I need something, I go search for it, you know, and chances are, my first option is going to be, okay, does the standard library does this? Does it do it? And I'll just use the standard library instead, even if there might be other packages out there that claim to be faster or prove to be faster. Honestly, because maybe it's a line of work I do, even if the same library version is a little slower than some third-party package, I may choose the standard library package because I know I can trust it more, right? I know it's always gonna work. I don't have to worry about somebody breaking, backwards compatibility or doing something shady, if I import some sort of third party, right? Like, to me, like, the risk, right? I lean towards standard library every time whenever I need to make those kinds of decisions. Okay.
Yeah.
So that's those are the packages, that's the functionality, that's where those things kind of live. So let's switch back to the code here. Right, so this is what that dial function is about. Okay, so remember, in order to use that dial function, I needed to import the net package, right? And then here I can actually use the net dot and then use the function from that package to actually use the behavior user functionality. So the second lesson you're about to learn here, or is this the second or is this the third? I can't remember. But the next lesson you're about to learn here is that in Go, typically, especially if you have something that's talking over the network or doing something that potentially could have a problem, right? Maybe you're trying to decode something where there could be a decoding error. Maybe you're trying to make a request. There could be a request, or whatever the case may be. Typically in Go, and one of the things that you either love about Go or hate about Go is that Go makes you handle errors explicitly. Go doesn't have the concept of exceptions, right? There is no exception handling in Go, right? There's no throw, catch, finally. There's no try. There's none of these. Those keywords do not exist in Go because Go makes you treat errors like any other variable, like any other value, right? Right. So basically, if you mouse over this dial here, or actually if you go back to the documentation, which is a little easier to read, let me bring it back here. Right, let's find dial again. Where is it? Where I lost it. Where is it? My goodness. See, there's so much stuff in here.
There you go.
I lost it again. There you go. Dial. There we go. Oof. All right. So notice what gets the return values here. So this whole thing is your function signature, right? So you know what your input needs to be. So we're going to send in a network and an address, both of type string, right? Oh, and by the way, Go is a string type language. This is it's a compiled language. So your types, you're working with types all day long, right? You can't omit types when you declare something. So we know expect both network and address to be of type string. And what's going to come back, we're going to get two values back. One is going to be of type connection. So if I click on this, that's going to take me to the connection type, which is actually an interface. We're going to talk about interfaces a little later on. But that's whatever value is going to be returned is going to satisfy this con interface, right? Let's go back here. And then the second value that's going to get returned is something that satisfies the error interface. So if I click on error here, you're going to get so this is the error type, which is also an interface. So that means that anything that gets returned, right, that is from calling net.dal, both of those values are going to be of type. The first value is going to be of type connection, which is an interface, and the second value is going to be also going to be a type error, which is an interface. Okay, so that means that in our code, when we to capture the results that come back from net.dal, I have this con here variable, followed by a comma, followed by an error variable to actually capture the two return values that are going to come back, right? That thing that satisfies the connection interface and that thing that satisfies the error interface, right? And then this is the part of Go that bothers a lot of people coming to Go and having to sort of handle their errors explicitly. This if error not equal nil, that it's like a mantra. You're gonna have that spread in your Go code, sort of like in a lot of places, right? Yeah. You can do some more sophisticated things about error handling and whatnot, and again, it can get a little more complicated, but for the vast majority of cases, you're going to get a lot of this sort of error checking, right, happening after you do anything of significance.
I did see someone actually that created a function, and every time you get the error message, it just pass the error variable to that function, and so they don't keep writing it everywhere in the code.
Right, but the downside to that is a lot of times when they do that, this usually it's like a check error or whatever it is they tend to call it. But usually what they're doing is basically like doing a panic, right, inside of the body of that function, basically saying, hey, when I check this error, if there's an error, I want to panic. don't panic. so like when you're writing sort of simple sort of toy programs, whatever it is, yeah, you can panic, whatever it is. But when you panic in your Go code, what you're basically saying, hey, like, I want the world to end for this program. Like, crash, bring everything down. Like, unless you have some panic sort of recovery in your code, which is sort of a different topic that we won't touch on today. But you can recover from panics. But it's a very destructive way. Like, it's basically you're trying to use that as a sort of a branching mechanism, or as an error handling mechanism, when you really shouldn't be, right? You panic when something really truly has gone wrong, and your program shouldn't even be functioning. And for the most part, if you're trying to write stateful services, if you're trying to write things that should be long-lived, like take, for example, a web server, right? You want your web server to, even if something were to go horribly wrong, you want your service to still be running and taking in incoming requests. You don't want the whole process to shut down and sort of go away now for your load balancer to try and wait for another thing to come back and take its place while requests are still coming in from the internet, right? So typically you want to handle those situations and say, oh, okay, like something really bad went wrong. Log it, send it to some sort of external exception tracking, whatever you want to do. But a panic is really, like, especially unrecovered panic, is the last thing you want to do in your programs, right? You want to clean up after yourself a little bit, okay?
Sure. And it can get complicated too if you try to handle switch. You do switch case. If it's this type and that type, it can get ugly.
Right. Yeah. It's the bottom line is, avoid trying to use panic in your code. I have a strong rule around using panic. If I see, especially around libraries, if I see panics in library code that are imported and used by other programs, I'll usually frown upon that. If I see a panic anywhere in your code other than your main file, then I'll frown upon that, right? So usually there's some best practices you can follow around the use of panic, but most of the time it's this. In 99% of cases, panic is not what you want to reach out for, right? You want to log and clean up after yourself and allow the program to keep living on and moving on, if it is indeed something that is production grade and not a toy program. Okay.
Gotcha.
So here we are. So basically, what we're doing here, remember, our dial function is sort of handling that sort of that whole establishing of a connection for us. Remember, back in our diagram, we saw how the client was making a connection to the server, sending a synchronized packet, and the server was then saying, hey, I'm going to acknowledge your synchronized packet, and then the client then sent the additional sort of packet before they establish our connection. That whole thing happens for us under the hood, with the dial function, without us having to actually, do packet, sort of handling ourselves, right? We're working at a much higher level of abstraction there, but the dial function would actually facilitate that exchange for us. Now, what we then do, how we interpret the errors, and there could be a number of reasons why error happens, right? Maybe there's nothing running on that behind that port. Maybe you can even make that connection. Maybe the connection timed out, right? If you try to connect something that has a firewall that prevents communication over a certain port, maybe you're blocked there, right? So there could be a number of reasons why you can't establish a connection. So the dial function is going to basically, give you an error back. You can interrogate that error, figure out exactly what went wrong. But for our purposes, here we're going to say, like, if for whatever reason I couldn't connect to this on this port, I'm going to consider that port closed, right? That's all we want to know about, right? Can I establish a connection to that port? Yes or no, right? For whatever reason I can't establish a connection, I don't care. Can I establish a connection? Yes or no, right? So the moment we get an error back on the dial, so basically that error value is not going to be nil. That means something went wrong. That we're going to consider that port closed. So we just output, right, using our log package in the fatal F function. The fatal F is actually going to emit something out and exit our program. So it's a nicer panic, if you will, but it's not a panic. It's an actual clean exit of the program. So we're gonna print something out and then we're gonna end the program. Okay, and then but if error wasn't nil, if the dial successfully established a connection, so that whole handshake process took place, right? Then by the time we get to line 15, we assume that yes, that connection is live. We explicitly close it because we're actually not going to be communicating over that connection. We basically, all we're doing is basically checking that it's open or not, right? We're going to close that and then we're going to consider it open. Okay, so very simple in its nature, and there's a lot of things I've glossed over here in terms of the language mechanics in the interest of time. But let's actually see the program running and what it actually emits. So here, by the way, I've hard coded the port to port 5001. And now we're going to see, and obviously as the program, all this code is going to be available. I'm going to share that on GitHub, by the way. All this code, all the different versions of this code, it's all on GitHub. You can actually take a peek at it. If you have questions, you can hit me up, and I'll be happy to explain. But again, we only have so much time together. We don't want to be here for 4 or 5 hours trying to explain every single thing. So, but the code's going to be available. You can hit me up afterwards. So let me then go into this very first. Let's see, is this the 0 is the simplest. So this is the simplest thing that could work, right? So we have our main.go file. That's a main.go file we've been looking at up here so far, right? So I'm going to do a go run, and I'm going to do that main.go. So that's basically the run will actually build the program and actually run it for you and discard the artifact. So typically, if I wanted to keep an artifact, I would build this program and get an executable, right? That I can then either put in as an image to be put in a Docker container, or I can zip it up, send it to a friend, whatever the case may be, right? But in this case, I don't want to build a program. I don't want to get an artifact. I just want to run the program. So it's behind the scenes going to build it, run the artifact, and then discard it for me when I do the go run. Okay, so I'm going to go run that go, and I'm going to hit enter. And here's what's happening here. So our output says, okay, for port 5001, so if I scroll, let me split the screen here. So this %d here, right, I'm basically, this fatal F is doing a formatted printing. This %d here, I'm going to feed this p value, which is this port that's on LAN 10. I'm going to feed this p value into into this placeholder. This %d means digit, basically. All right, I'm going to feed in this number because this p was declared as an integer. So I'm going to feed this p here to replace this placeholder, and I'm going to say close, and then I'm going to provide whatever error I got back. So this error value, which is captured here on line 11, I'm feeding that in here. So basically, I get the port that I'm trying to connect to, followed by the fact that I'm considering close, followed by whatever error I got back from the dial request. So this is what I'm looking at on the bottom here. So I have this 5001. Right, so the log functionality automatically will add, a timestamp for me. That's part of the log package. It just does that automatically. I have my port here, which is the 5001, and then I have the close string I typed in on line 13, right? And then I have whatever the error was, okay, from that dial request. In this case, trying to dial on my local loopback on port 5001, right? The connection was refused. So that means my operating system didn't really have anything on the other end of that port. There's no process. There's nothing bound to port 5001 on my machine locally to be able to answer that request, right? So we know it's not a firewall thing. We know there's nothing preventing me from actually establishing the connection. It's just that on our operating system, there's nothing bound to that port. Now let's try something a little different. So now let's try port 5432, which, if you know your Postgres, you know that that's a default port that Postgres runs on. And I happen to know that I have a Postgres server running locally. So if we actually run this program again, now with a port that we know, right, is running locally, let's see if our program behaves a bit differently. So I'm going to go run again. And this time, look at that. I get something a little different. I get open, right? So this is, that means we got to this point, right? Online, basically, we got past this log.fatal. The log.fatal, basically, once you get inside of this function, our program will end. In other words, when the fatal was printed out, right, our program ended right there. We never got to line 15. But if there was no error, in other words, if my dial connection was successful, right, I get to go to line 15. So again, on line 15, we have our connection, which basically we captured that variable here on line 11. We captured the connection. And so we're going to explicitly close it. Again, we're not trying to communicate over that connection for real. We're just basically saying, hey, we're just checking to see if it's open. We're just going to close it because we don't need it. And then we're just printing out a, hey, I can safely assume at this point that this port was open. And then that's exactly what we do here. I know you have questions, so jump in.
Johnny, ma boa chance pour un coup de scotch. Non, c'est très bon exemple. So, ça me voulait faire remarquer, c'est que si que vous pas comprendre ça qu'a fait là, that's okay. Mais ça me voulait faire remarquer, c'est que ça n'a fait aujourd'hui, c'est montrer qui gens
le que ou utiliser un web server ou bien ou un client qui a connecté à un web server qui est fondamental qui a passé dans le programme ou bien dans librairie qu'on va utiliser pour connecter à un web server. So, en pile fois, nous avons clients ou bien nous avons pas clients, nous avons des programmes à utiliser ou bien nous utilisons un package qui fait connexion pour nous. C'est-à-dire, c'est pas nous qui fait connexion directement. Et puis, package ça, il faut une série de bagages et puis elle prend information et puis porter le pour nous. So, ça n'a pas regardé c'est que si on utilise Go, mais qui gens ou même on doit créer propre programme qui sont clients pour connecter à un service et service ça li exposé sur un port quelque part. So, dans l'exemple ça port là c'est numéro 55432. Qu'on y a là nous même connaît ça qui service qui supporte là. Mais nous qu'à utiliser un programme que nous même nous écrit, j'en ai regardé sur écran pour communiquer avec service ça. So dans tout si nous même si c'est JavaScript via Node ou bien si c'est Python ou bien si c'est Ruby ou bien quel que soit le langage là, là que nous avons package ou bien nous avons librairie quelconque que nous avons utilisé pour connecter avec un service pour nous faire des requêtes, pour nous prendre information dans le service ça. Dans service ça, dans client ça ou bien dans librairie ça qu'on a utilisé, son bail comme ça quand même l'a fait ou que son code nous gagne qui établit en connexion directement avec un service reculé cap acheminé quelque part. So nous ne doit pas ouais que ça n'a gardé est très important, mais l'important dans le sens que li montre le que va utiliser on ça un third party client. C'est ça, c'est même bagarre là qui a passé en third party. C'est ça que je voulais ajouter.
D'abord dire que type de connexion, son connexion qu'on a fait en utilisant Python tout, on voit.
Absolutely. Yep.
Yeah, parce que Python standard library gagne on sait de built-in package qui permet de faire type de connexion là auto anyway.
Oui. Non, tout oui, tout programme, c'est-à-dire tout langage qui gagne dans figure gomba comme ça quelque part ou bien gon librairie comme ça au cas utiliser pour faire des connexions simples TCP/IP directement que ça va utiliser ou bien tout gagne des connexions HTTP qui ont un niveau plus haut. Mais ça n'a pas fait assez directement HTTP. C'est-à-dire ça n'a pas fait nous doit utiliser pour créer propre protocole pan. C'est une dévelé.
Yeah, ça fait Randall. J'aime pas Randall de Go. Randall, on pas besoin de ça. On compte pas.
No, actually, je commence à penser si c'est pas toi bon et ouais nous faire dans team côté mia parce que nous commençons à pousser to go with Ross. And m'a regardé simplicité Goa et you know ouais JP
changer les pas trop tard.
Hey, we'll take you back. It's all right.
D'abord dit même pas là tout parce que nous j'ai t'as depuis de commencer d'ab dit à Timon fait par Ross là et puis ça va faire à regarder type de travail on va faire data collection from like server switches and stuff. So quand on bagaille to go telegraph back on over tout telegraph c'est à go l'écrit.
Oh really?
Yeah, telegraph c'est avec go l'écrit. So et moi je utilise le telegraph tout so mal we so fait foot ça.
Yeah. No, that's pretty cool. So when m'a couille à l'advocate, m'a tant toujours et you know pour nèg va penser ça me s'est parlé là. C'est même pas celle nervous je dis. C'est tout dans Go encore.
Non,
toute l'année passée I've been talking about Go. when I was reading your book. Go ahead, Teaser.
Randall.
Oui.
Ou kon kes problem, ou nan ba eza?
Cobol?
Non, ou kon kes problem nan ba eza? Ou kon ki es?
Who?
Kon ki influence ou ki fò pran ou?
Who? Dark Fader?
Ah, ok, bon. Ok. So trial monsieur pour semaine prochaine,
But I mean, all seriousness, si que wap écrit des programmes pour faire ça le network programming, low level network programming, m'pas quoi pour but again, ça veut dire ou gen faire en C, ou gen faire en Python, etc. Mais goze yon un programme qui fait vraiment facile pour écrire propre service par ou bien propre client par ou. Et c'est une raison qui fait Go comme si nous dit rester toujours dans top langage pour créer ça les cloud native parce que cloud native chita sous ça les network comme si nous dit c'est cloud native de quoi le cloud native c'est service c'est networking etc. So c'est une raison pour laquelle que Go lui-même c'est une top language pour qui était dans zone ça parce que Go fait vraiment facile pour créer on the client side comme si vous doit créer client pour connecter à un service mais en même temps tout on the service side vous doit créer service. So Johnny peut montrer nous how easy it is to create a service with Go, but it's just as easy. So I'll let him continue.
Nah, this is good. This is something, maybe you bring me back and then we talk about how do you create services in Go. We talk about that and see how easy that is, right?
Yeah.
Awesome. So I'm gonna use about 5 more minutes, right, to show you sort of the progression of how these things get more complicated. So what I'm gonna do is I'm actually going to jump to one of the more complicated snapshots or versions of this program, right? Skipping a couple of different steps, just to show you the sort of the power of Go beyond just the basics here, right? So I want to show you, even if not everything makes sense before I show it to you, or when I show it to you, you'll get an idea of sort of how powerful Go can be, right? So you've seen the simplest version of this program, right? So we know we can, basically we've been using hard-coded version of the port. But all the subsequent versions of this program, they follow the same basic principle. You are going to establish a connection, you are going to handle the error, and if there's something comes back and that's an error, you know that the port is closed. So that core nugget there doesn't change at all. So all of the other versions of this program, they follow the same basic principle. Now, what we are going to do, right? So we're gonna evolve our program a little bit from using a sort of a hard-coded port. Remember, we're trying to write a port scanning solution, right? So we can't just have one port that we're checking. So that's not really scanning anything. That just says here's one port, see if it's open, and then you're done. So how do we make this a little more interesting? So the next evolution of this program is where we actually try to do a loop, right? We're trying to loop through a number of ports, right? So again, if you look at the body of this program, same basic concept, right? We're doing a net.dal, handling our result, right? The only thing we're doing now that's different is we put a for loop, basically, that says, hey, I'm gonna go from port 5300 to port 5500, okay? So I'm gonna scan a couple hundred ports, right? And see in that list, which one of them is open or closed, right? So that's the only thing we've added to this program, except obviously doing some basically checking to see if a particular port. So if the first time we see a port that's closed, we don't want to, rather than what we're doing before, which is a log.fatal, right, which would end the program, we've switched over to a log.print, which is basically just print it and don't stop the program, just print something out. And then basically we're just gonna skip over to the next iteration of the loop with this continue statement here. So this is how you do, this is one way you do loops in Go. Then other nice thing about Go is that there's only one way to do loops in Go, using a for keyword. So unlike other languages, there's no do while, there's no while, there's no other variations of how you do loops in Go. It's just one way, one keyword, for. Only one. It might sound limiting, it might sound weird, but you can actually represent all of the other variants of looping with just this one for construct. right? It's quite powerful, which is another thing I'm saying. Like other languages have lots of different ways, they're expressive. They want to offer you all kinds of different ways to actually do the same thing. Go's like, well, why have 3 or 4 if one will do, right? That's kind of like the Go, really, like the ethos around the Go community. Like, pick the simplest thing that can work and stick with it, right? Like, we don't need all kinds of magical, clever things, right? So here it's just basically we're just doing that looping, and then let's actually see how this program functions. So I'm gonna open the sequential version of this program, and I'm gonna go full screen here, and let's do go run main.go. And here we are scanning a couple hundred different ports, right? In which it did so very quickly here. Couple hundred different ports, and basically the same output we're going to before. Every time we consider the port closed, we get this connection refuse emitted out. So if we scroll up a little bit though, amidst all of this close, here we are again, port 5432, which we happen to know, right, is where we have our local Postgres server running. So here we are, we've scanned a couple hundred different ports in what really seemed like 500 milliseconds. And so we got our results, right? A couple hundred different ports, and we found the one that's open. Okay, so let's now look at sort of an evolution of this program. So before we do that, though, what you must understand is that when you're doing things like port scanning, or really any kind of work where in a loop, as it were, any kind of work where really you have no dependency from one operation, right? One iteration of your loop. There's really no dependency from one iteration to the next. In other words, I'm scanning a port, whatever that port number happens to be. Well, I'm not waiting on the results of that before I can actually scan another port, right? So there's no dependency on this. This falls in a class of problems called embarrassingly parallel, right? So what we're trying to do here is basically say, hey, like, why do I, even though this scanning operation was pretty quick, we only scanning a couple hundred ports, we were able to do that in less than a second. That's great. But what if I'm trying to scan thousands of ports, right? There's really no dependency between scanning port 5000 and scanning port 5001. There's nothing there. I don't have to wait for one to the other. So this is where we're going to start to dip our toes into Go's concurrency sort of a mechanism, and how it sort of enables that, right? So in Go, to actually be able to use Go's concurrency primitives, one of the things that you're going to hear about with regards to Go's concurrency that sort of may make you curious is the concept of what's called Go routines. Your Go routines, and you're going to see here, in other language communities, you may come across things like called coroutines, like CO instead of GO, right? Coroutines, or you might hear a more accurate description of Go routines might be lightweight threads, right? Which are much lighter than say Java threads or operating system level threads, right? Those tend to be a lot more heavier weight than getting Go routines. So the Go routines basically allow you to have thousands, right? Hundreds of thousands of Go routines happening at the same time, all being managed by Go's own scheduler. In other words, right, your Go runtime can actually use just a few operating system level threads, okay? But because you still need to interact with the operating system, your Go scheduler will use a handful of operating system level threads, but actually multiplex all of your Go routines across these operating system level threads, thereby creating this sort of this abstraction between what you consider a thread as a developer, between what the operating system considers a thread. So because at that point, if the Go scheduler is actually managing those threads for you, right, you're not at the mercy of the operating system, which could pause your thread at any moment to switch to a different thing. Okay, so what makes Go and its currency story so good, what really attracts people to the Go language, is the fact that Go routines allow you to write multi-threaded code, but you don't suffer from the same sort of pauses or issues that might come if you were at the reliance of the operating system managing your threads for you directly. Okay, again, I know that may be sort of a one level of abstraction until you can actually see it and experience it, right? This is going to be all theory, but let's actually see how we start leveraging these things in practice. So let's look at this version of this code where we're trying to then leverage Go routines. So again, the core of the functionality hasn't changed, right? We're still using the net.dial. We're still establishing connection, handling our errors, and making a decision whether the port is open. Same thing, the body hasn't changed at all. The only thing that has changed now is that we want to leverage Go routines inside of our loop. So which we want to launch. So we're about to scan from port 5200 to 5500, right? We want to scan 300 ports, right? But the idea is because one port scan doesn't depend on another, we're going to launch, in this case, about 300 separate Go routines, each one of them doing, facilitating the port scan, right? Using this Go keyword in front of an anonymous function in this case, right? We're actually launching a new thread of execution for each one of these port scans, right? So each one of these is going to run its own thread. Okay. So now let's actually see, this. I don't know. They say Go routines, using Go routines in Go is quite easy to do, right? I know Vladimir is already seeing what's wrong with this code, but let's actually run it and see what happens. Let's clean this out here. Let's go to this version. And let's do go run main.go. Here we go. We're going to run about 300 different Go routines. And it's going to be awesome because it's going to do this thing so much quickly. Wow. That was too quick, huh? Wow. Did it really launch 300 Go routines and actually do port scan for all these things? Let me run it again. Done. Wow. What's going on here? It actually didn't actually do anything.
Nothing.
Yeah, exactly. You didn't give the program a chance to actually do anything, right? Because here's what happens.
I was talking about what's wrong with it. I still not.
Yeah, so when you launch a Go routine, you're actually launching a separate thread of execution, meaning now that this thread, whatever's happening here, it's its own life cycle. If it's its own thread, it has its own thread stack, it has its own memory space, it has its own everything. So it is doing what it needs to do separately from your main Go routine, right? Which is the one that it was launched from. So we just launched 300 Go routines, and the main thread is like, okay, I've launched these things, I'm moving on. Meaning that after you went through this loop and you ran all these Go routines, your program jumps to line 21, prints out done, and it finishes, it exits.
I see.
It's like, I'm out of here. Because you didn't tell it to wait for anyone. You didn't tell it to hang on, wait while this work happens elsewhere. You just said, hey, launch these Go routines and then print something out and then bail out. So that's exactly what it did. So this is where you bring in the concept of synchronization. You need to synchronize, right, your separate threads of execution. You need something. You might hear the concept of a joins, right, with threads. And say something like Java, right? You have to rejoin the separate thread the main thread. Exactly. So that's actually how we do that in Go, real quick.
I thought you were going to talk about channels.
Oh, yeah. There is, and the good thing is, you see, there's like 6 different evolutions of this program.
I see.
We do hit on channels, right? We may not have enough time to cover it all, but I'm gonna make the code available. But yeah, yep. Go ahead, Vladimir.
Non, ça m'a pas ajouté, c'est que une barrière pour nous remarquer, c'est que facilité pour leur utiliser Go pour créer programme qui a acheminé, non, pas complexe, non, mais qui a acheminé ça à faire concurrently, couramment. C'est-à-dire, ou bien doit non seul programme fait plusieurs bagailles en même temps, ou bien s'il pas en même temps, Go apprendre qui j'ai pour tant que Johnny te dit schedule ou bien ranger ça l'a faire en genre comme c'est pour le montrer que ça l'a faire yo ka fait en même temps. So c'est une bagaille que Léon moun saute non langage tant que Python pas gain facilité ça, Python pas ka fait ça les threaded programming, right?
Yeah.
Right, because of the global lock or whatever it's called. Mais loving Go on programme comme Python ou bien even Ruby, I'm not sure about Node. Ou vin dans position que kounya ou gen doit écrire un programme et puis qu'on y a John était dit tout à l'heure, si programme a fait des tâches qui a fait en même temps, qu'on y a doit réarranger programme que tâche ça ou task yo ka fait couramment comme si on dit presque go apprend sans ni que même tâche ça si yo ka fait indépendamment de une l'autre go ap launch tâche ça pour yo acheminer pour yo faire ça faire pour compte yo on their own thread or thread pour compte pas mais c'est pour bagage que ou joindre dans tout langage. So c'est ça me voulais ajouter que ou pas joindre fonctionnalité ça le fait que ou ka fait le fait que ou ka font programme et programme dans lui-même ka acheminer des tâches concurrents ou pas joindre niveau de sophistication ça ou pas joindre niveau de facilité ça
simplicité ça alors
simplicité ça exactement simplicité ça dans tout programme. Go ahead.
So te plaisir en général c'est que créer un routine dans Go tellement comme c'est tellement facile et simple que on peut créer comme si plusieurs sont pas écrits en top code.
So exactement. Exactement. So
parce que
go ahead. I'm sorry.
Parce que le m'a regardé routine ça effectivement. Je me dis quête monsieur. Bon, pour me faire bailler ça dans Java même.
Oh yeah. That's crazy.
Doing background like
right.
Background
exactement.
task tout bailler ça so yeah, donc c'est pratiquement ça mon côté plaisir.
Exactement. So dans Go, le fait que vous avez les keywords Go ou placer devant fonction, so that block ça, qu'on y a vient tourner en tâche que vous avez exécuter concurremment. C'est-à-dire, Jean-John était dit, main, côté nous main a vient tourner c'est-à-dire en ligne d'exécution et puis lui-même il pourra launch, il va commencer en l'autre task, en l'autre tâche pour. Mais pour comme on dit si c'est un autre langage extrême, il va être extrêmement difficile, mais là difficile.
Yeah.
Il pas directement comme ça. Et il y a des programmes tout qui pas même supporter ça même.
La bonne dans pile.
Exactement. T'as Python
Java.
Right, exactement. So c'est point ça me voulais faire.
Good stuff. Now let's see how we can actually fix this program, which we're on the right path. We're launching a whole bunch of different threads of execution, but we need to make these guys wait, right? We need to actually make the main thread wait on these other threads that we're launching, right? So I can actually get the result back before we proceed. So this is where we introduce synchronization into our program. So this version of the program, right, and there's a few more things going on here, and I'll quickly gloss over some of these. They're not as important for what the part of this that we actually want to focus on. But really, all I'm doing here is parameterizing the program so that when I launch it, I'm able to specify a different port or a different port range, or from port to port, that kind of thing. So I'm just parameterizing this program, right? So basically using the flag package to set flags. So when I run this program, I can say dash flag name and then some value, right? I can change that way it's not hard coded into my program. Okay, that's what's happening here. And then I have a flag.parse, which is picking the values from there. All this is part of the same library. I don't have to bring in a third-party package or anything like that to actually write very robust command line applications, right? I can actually use the standard library to actually take advantage of all kinds of goodies, being able to read values and arguments when I launch my program from the command line. I can do all that stuff without actually having to bring in any third-party packages. So what I'm doing here, and for this FP and this TP, is basically FP is basically from port and TP is to port. So remember, I'm scanning from a port number and then going to a port number. So that's what my FTM and TP are. I'm using this Fmt package, basically, which actually does a string conversion. So it'll actually take in the when I invoke my program, the values that I'm passing in from those flags that I've declared up top, they're going to be strings. And because I know when I need to actually scan my port, I need actual integer values and things like that. I'm using a Fmt package to actually call on the A2I function, which is basically Ascii to integer. That's what it's short for. To basically say, hey, here's a string, give me back a number, right? And clearly, when you do the conversion, if the user sends in a letter instead of a number, something might go wrong. So this is what I'm doing here with handling my errors. So again, the whole error handling thing, you're gonna see this if error not nil pattern like all over the place. And that's okay. It might annoy you at first, but you'll get over it. Like literally these days when I'm reading Go code and I see this, my eyes literally glaze over it. Like I'm able to follow the sort of the important things. It's not that big a deal.
Actually, if I don't see it, I assume something's wrong.
Something, yeah, you're doing something wrong. Why are you ignoring your errors? Exactly. Right. So yeah, so we've got our from port, we got our to port, and then basically here I'm just doing a quick validation, making sure that you didn't give me the like a smaller number for the to port, right? In other words, I'm not scanning backwards, I'm scanning forward, I'm incrementing, right? And basically I'm just doing a quick check here. Again, all this stuff is validation, but this is where the meat of our fix, right, for our previous the previous version of the program comes in. The standard library, you gotta love the standard library. It provides you all the tools you need to do this right. The standard library has what's called a sync package, and you might imagine what the sync package is. It basically provides synchronization primitives for dealing with concurrency and the Go ecosystem. So the sync package, right? And I'm gonna pull up the documentation here and quickly show the sync package, right? So basically the sync package provides basic synchronization primitives such as mutual exclusion locks. In other words, mutex. You'll hear that terminology. You have things like once and wait groups and things like that. All these mechanism exists to help you sort of manage concurrency within your Go code. Okay, so I've just pulled up a utility here, but you can easily pull that up inside of the this as well, inside of the go.dev. So if you go back here and you go to the sync package and you do that, this is the same exact stuff I was looking at. I just happen to have a utility for quickly pulling up documentation. And by the way, this is called a dash. So it's like a quick heads up display. I can pull up documentation wherever I am on my operating system. I just hit a quick keyboard shortcut and I can pull up documentation on virtually anything that I need. So be it like I have all kinds of goodies, be it
I need that, dude.
Yeah, be it Ruby code or Scala or whatever documentation I pull from anywhere. I have all that at my fingertips with just one keyboard shortcut. So it's called a Capelli dash. Yep, that's capelli.com. That's what it looks like. So highly recommended. And I don't get a kickback for this. I've just been using this tool for many years, and it has made documentation lookup extremely easy for me. Again, a quick keyboard shortcut and boom, here I have it, and I can pull up documentation on anything. It'll search all my documentation regardless of language, regardless of technology. It'll search all that and bring it quickly at my fingertips. So really good stuff.
Cool.
All right, so let's go back here. So the sync package, in the sync package is something called the wait group. There's a type called a wait group. The wait group, as the name implies, right, is going to provide some waiting mechanism, right, for our Go routines. So how do we use this wait group? The wait group, once we initialize our wait group here, we have this variable called WG, short for wait group, and I'm gonna add this add here is going to track. I get to add the number of things that I want to wait for, right, in my wait group. Okay, and we're gonna see why that's important here in a second. But the idea is that we know that we're about to launch, right, however many number of Go routines I'm about to loop over in this case, but my default, so if I scroll back up here, my default in this program is I'm going to go from port 8080 to port 8090. So I have about 10 ports here, but remember I've parameterized these because I want to be able to provide large port ranges when I scan this. So, but by default, I'm going to scan, just 10 ports. But when I do this loop here, right, however many ports I'm looping over, right, what's going to happen is for each one of those go routines, one of the ways you actually get, so to indicate to the wait group that one of your things is done, right, is to actually call this done function, which is actually going to subtract 1 from whatever total count you added in this wg.add. Why are we doing that? Well, it's because of this wait, wg.wait down here. Okay, so remember, our program, the previous iteration of our program basically said, okay, I'm going to launch all these grow routines. All right, let me actually bring it up so we can actually compare it side
Looks
by
like
side.
an observer pattern.
Yeah, you can think of it that way. You can definitely think of it that way. So let me actually put this side by side so we can actually see this program. Let me zoom out a little bit, right? So on the left-hand side is the program that was too fast, right? We weren't waiting for the separate threads to actually finish the work. The program just ran too fast. Our main routine basically launched these things and said, hey, I'm done. I'm out of here, right? And it didn't wait for the other ones to finish. This version of the program, we want to wait, and the way we do that is by using this sync wait group, and it has a wait method on that WG. That wait is a blocking call, meaning that when our program launches all of its go routines, right, our main go routine is going to get here on line 53, right, and actually sit there and wait. It's going to force a wait until all of the go routines that we launched, right, until all of that work is done. Well, how do we know it's done? Well, we remember here we're saying, hey, I'm going to add the total number, right, of the number of grow routines that I'm going to launch. So in this case, it's 10. So I'm just doing a quick subtraction here, saying, hey, the 2 port and the from port, whatever those numbers happen to be, I subtract them, and that's the number of things I have to wait for. Okay, and then now every time we launch a grow routine, the only thing we have to do is call this wg.done. And every time for each one of those grow routines, every time this wg.done gets called, 1 gets subtracted from that total number we added. So if we started at 10, right? So every time a grow routine gets done, 1 gets subtracted. So I go from 9 to 8 to 7 and so on and so forth. Okay. Thereby here, this guy's just sitting here waiting for the counter to finish. Right, as the grow routines get done with their work, it's just sitting here and blocking and waiting. It says, oh, there's still 2 more. Oh, still 1 more. Still, oh, okay, we're done. There's no more things that I'm waiting for. Now the main grow routine gets to resume, right, and our program gets to finish. But this is how, right, and if you've seen people like when they're doing multi-threaded programming and they're using time.sleep somewhere, like that's a bad. Don't do that. That's a very bad thing. That's usually what they're trying to do, right? Like trying to guess how long this thing's gonna take. Let me wait for 10 seconds and see how long I have to wait for this thing. Yeah, don't do that. That's a very hacky way of doing that.
If you're sleeping,
this is why
you're snowflaking all over the place.
This is why I have promises in JavaScript.
Right, because you want when the thing is actually done, right? You want to be able to move forward or do something with the result, right? You don't want to guess as to when it's going to be done. Whatever time.sleep is on my machine, it's going to be something completely different on your machine. It's going to be something completely different on the server where the thing runs on. Like that's it's great for example, like playing around code, but not like you want to actually use the concurrency mechanisms for this stuff, right? So basically, this wait group actually allows us to have this clean mechanism. So let's actually see this code run, and this will be sort of the last thing. Oh, go ahead.
Johnny, I think you should add a print done after the wait.
Yeah, let's do that. So I'm just gonna copy this here, and I'm gonna put some here. Okay. So what I'm gonna do here, I'm gonna say waiting, so I can actually see what's happening, right? And then now I'm going to run this version of the program. So the synchronized version, I'm going to do go run, right? I'm going to run that. So by default, I have just 10 ports, right? I didn't specify, I didn't override those values, but you can actually see the output, right? So you see the waiting, right? That got printed immediately after I launched all my grow routines. Like that was our program, right? So if you bring back the code here, let's close this, right? So we launch all these grow routines, all 10 of them in this case, and then we immediately move to this waiting line. So if we didn't have this wg.wait, we'd have had the same exact problem we had last time. Our main routine would not have waited around for these other routines to finish. Okay, so we have this waiting here, right? That's the first thing that gets printed, and then we block the main routine, allowing the other stuff to allowing the work to finish, and then once that's done, right, you get your, as we're printing out here, you get this done printed out. So that's how you synchronize your main routines. Okay, right. So I know we've been talking for a while. That there's other considerations that you should have around the use of Go routines. You don't want to sort of launch them. You don't want to launch thousands of these things, because at some point you're going to run into what's called, in this case, unbounded concurrency problem, right? So sometimes you can have too much concurrency, meaning that in a lot of classes of problems, especially when you have your code interact with a third-party system, be it maybe a remote API, maybe some sort of remote system, or whatever medium of communication you're trying to use, maybe something on your local operating system, right? There are going to be constraints around your program, right? That really have nothing to do with your Go code. In other words, so if you've ever been throttled by a remote API, so for example, if you have code where you're doing a loop and you're making HTTP requests to some sort of API, at some point, you're going to get back, some HTTP error code that tells you you're making too many requests too fast. So if you ever read about API, public APIs, and when it says, hey, you're gonna get throttled unless you keep your maximum request to say 10 requests per second over a 30 second window or something like that, right? If you exceed those number of requests, right, for that given time period, you're gonna get throttled. They're trying to manage the resources, right? Because you might not be the only program. Yours might not be the only program trying to communicate with that system. So they need to manage the resources, so they can't let you exhaust their entire sort of a system, and then prevent other users from actually connecting and actually making request data as well. So they may throttle you, right, if you start making too many requests too fast. So in that scenario, Go is not your bottleneck. Go is doing things very fast, right? But sometimes you want to control how fast it does things, right? So you can quickly run into unbounded concurrency problems depending on the kind of problem you're solving. And really, this is where, like, for example, to actually illustrate this, and I promise we'll start to wrap this up here. I don't know how long we typically go, but this conversation has been so good. Like I keep going down the rabbit hole with y'all. All right, so if I do go run.main, so same program we had before, and then I'm gonna say from port 5000. Remember, before we were scanning port 80 to 90, or 80 to 89. Those are the defaults, right, in our program. I'm going to override those defaults by providing those flags here. I'm going to say, hey, I want you to start from port 5000 to port 8000. So I'm gonna scan 3000 ports, meaning that I'm about to launch 3000 Go routines, right? So I don't know about you, but that sounds like a lot of Go routines. So here I am launching 3000 Go routines. I've got scanning happening on each one of those things. Let's see what happens to our program here. Same exact program. Let's see what happens. It's launching. The port sequence is out of order. We know it's doing things. Each Go routine is working on any one thing. There's no sequence here. It's picking up. It's doing its work. Let's see what happens. Ports are scanning. Ports are scanning. Oh, what happened here? What is that? Something blew up. This. What is going on? What is going on? So
you ran out of memory.
Well, we didn't run out of memory. Our operating system said, "Yo, dog, what are you doing? What are you doing?" Right? Because every time I try to connect over a port, right? Especially because this is a Unix-based sort of environment. Everything in the Unix world, right, is a file. Right, so I'm opening up a socket, right, which is basically under the hood is a file, right? I'm opening up a socket to try and make a connection, right, to another process. So any given service within an operating system, right, has limits on how many of those things they can have open, right? Every process is going to have a limit on how many files they can have open. Every process is going to have a limit on what they can do within a given environment. So a corollary to that might be, so for example, if you have a process that you're packaging up as an image and putting that's going to run in a Docker container, sometimes there will be limits put on your Docker container that says you can only use X amount of CPU, you can only use X amount of memory, right? So there are constraints around your program that you must sort of be aware of when you start to actually write your code. You can't say, oh, I'm gonna be, it's YOLO, I'm gonna be launching as many routines as possible to try and get this work done as fast as possible, because your constraint is not the language. Your constraint exists outside of the language. It exists outside of your program. You have to worry about the system that you're working within. So what happened here is that our operating system basically told our program, yo dog, like you're opening up way too many file handles, you're using up way too many sockets. I'm gonna stop this program. So our program just comes crashing down in the worst way. All right. So how do we then manage the number of Go? We still want to use concurrency, right? We still want to use the power of Go. We still want to do things as efficiently as possible. But how do we manage the number of Go routines that can be working on this problem of ours at any given time, right? How do we bound this concurrency problem? Well, that's where worker pools come in. So let's actually take a quick look at a worker pool. So a worker pool, as the name implies, and I'm sure you all have come across worker pools before, is that you have as the name implies, a pool of workers, but it's a set number of workers that on any given time are working on a backlog of work for you. In other words, I have 3,000 ports to scan, but I really want to have at most maybe, I don't know, whatever the case may be for you, maybe 20, maybe 30, maybe 50, maybe 100, or whatever you decide, like workers. In other words, Go routines, right? Working on scanning a port at any given time. In other words, yes, I may not be able to launch 3,000 Go routines and dedicate a Go routine for each scan, but I can have a pool of 100 workers chewing through the task of scanning through 3,000 ports, right? That's still going to be faster than trying to do it sequentially, but it's not going to be so fast, or you're not going to be just so many resources that the operating system has to intervene and end your program. Right? So by actually using a worker pool, you're allowing the concurrency mechanism of Go to actually help you out and help you get through this work, but you are controlling the number of Go routines that can be working at any given time. So how do we do this? So again, we have the same basic things we were doing here before. The only difference now is that we have a port range that we can specify, and we have the number of workers which we are defaulting here on line 22. We are defaulting that to the number of CPU cores in my machine. So I'm on a MacBook Pro 2018 or something like that. So I have probably like 8 cores available on my machine, 8 CPU cores. So what I'm saying here, at any given time here, I'm going to have 8 Go routines, doing the work. Now I've picked, this value sort of as sort of a good starting point, but you may tweak and do whatever you need to do based on the constraints that you're working with to figure out, what's a sweet spot for me for this problem I'm trying to solve. What is a sweet spot for the number of Go routines I actually have running at any given time, right? But this is just one way. That's just my starting point. This is something you can adjust, right? And obviously, because it's parameterized, I can actually override the number of workers I have at any given time. So this would allow you that if you know that locally, you're working in with a number of CPU cores. Maybe when you deploy this program and you're going to have a very beefy set of servers available to you, maybe you override that to say, hey, I want to have 1,000 workers, right? And then the operating system obviously is going to be tweaked to allow for you to have, at any given time, 1,000 file handles or something like that, right? So again, the constraints here are you parameterize your program so that you can work with the constraints that you have. Okay, so here we are, and these are helpful functions. I'll let you sort of play around with those separately, but this is actually where we're actually making use of channels. I know, Randall, you were asking about channels earlier. We're actually making use of channels here to basically track, and again, I'm going to do a hand wave over some of this in the interest of time, but this is where I'm actually making use of channels here to keep track of the number of workers that I want pulling up work from, to actually do the port scans, and I'm keeping track of a channel to actually feed in the results of the work that's actually being done. And then what I'm doing here, basically, I'm launching on line 38. I'm launching a new worker, right, with the host value that and the worker. If I mouse over it here, you'll see the signature is give me the host that you want to scan. give me the list of integers, the ports that you want to scan on that host, right? And then give me the results channel where I need to send the results out. So this worker gets everything that it needs to actually be able to do the work. It gets the what is the host that I'm going to be scanning, and feed into me, please, on a regular basis, right? Not all at once, but feed into me every time you want me to work on a port. Feed that into me, right? And as I get done, I'm going to put the results of that in the results channel, thereby making an asynchronous, right, mechanism to actually take in work and to put the results of work, almost like what you might think of a JavaScript promise, but using channels as a mechanism of feeding in that work and sending the results back out. Okay, so the worker is not going to is not going to return any results back. The worker takes in the channel where it's going to pull the work to do, and it also gets the results channel where it actually should send the results. Okay, so the function call doesn't return anything. The results of the work get put into the results channel. Okay, so very subtle use of the worker here. Okay, and then here we launch our Go routines. We launch a Go routine whose entire job is to feed ports into the port scan channel. So as I feed ports into the port scan channel, whatever workers I had launched, right, which have the port scan channel, they're gonna start to see ports come in for them to do work. So as the ports come in, they're doing the work, and as they get done with the work, they feed in the result back into the results channel. Okay, and then what we're doing here, so basically we just have open ports, a slice of integer here. Think of this as an array, but the array is managed for you by with the slice concept, right? So again, I'll sort of hand wave over the difference between a slice and an array. Go has both, but generally speaking, developers tend to use slices 9 times out of 10, unless you have a very specific need for an array, which is a fixed size container, fixed size list. Typically, you're going to want to use slices because the size of the underlying array gets managed for you automatically by the runtime. So typically you want to use slices instead. And the difference between a slice and an array is typically there's a number. So for example, here this slice, this is an array with 4 elements. You can only put 4 things in there. If you don't have a number in there, that makes it a slice. That's the only difference. Okay, but the slice is much more flexible, right, than the array. All right, moving on. So, but here all I'm doing is basically I'm reading. So you see this left arrow operator here. I'm reading from the results channel. So remember, back up here on line 43, we're feeding in ports. This P, it's our list of ports that are coming from our ports to scan. It's our list of ports, right? I'm feeding in a port, right, into our ports channel. And as those Go routines get through the work of scanning our ports, they put the work in the results chain. But I still need to read results out of the results chain, right, to actually do something with them. So in this case, what I'm doing is actually using the left arrow operator. I'm reading a result from the results chain, assigning it to the variable P, and I'm basically saying, hey, if the P is not 0, in other words, in this case, remember, I'm setting in port numbers in there, right? So, if the port is closed, basically my worker is going to put 0, right, to indicate that the port was closed. Anything that's non-zero is going to be the actual port number, right, that was open, right? So in other words, that's why I'm doing this check here. I'm basically saying, hey, when I read this value from the results channel, so my Go routines are doing their work, putting the results in the results channel. When I read that port back out, if it's 0, I know it was a closed port. I don't really care what port it was. It's just 0. I don't care about it. But if it was anything other than 0, but it was one of those ports that was open. So now I'm just appending to my open ports here. I'm just now collecting and accumulating all the ports that were deemed to be open. And then all we're doing here is we close our channels after we're done feeding things in, after we're done reading things out. And basically here I'm just using the sorts package, also part of the standard library. And I'm sorting my list of ports, right? Just to get an ordered list of my ports, nothing special. And I'm now ranging over, which is basically range over is kind of like doing a for each in your favorite programming language or something like that, right? That's what when you're looping over things in Go. This is another, again, using the for keyword, right? The range is another way of doing for loops in Go, right? So for range allows me to look over the list and then print out my list of open ports. So let's actually see this program running now. Using the worker pool pattern, I'm gonna do go run.go. and I'm going to pass in the same 3,000 ports that I wanted to scan earlier. Remember earlier, 3,000 ports, my program sort of blew up, sort of halfway through. Now let's see if we run this program again, this time using the worker pool. Whoops, am I in the right folder? Oh, I need to change the
JP, is that you with the music?
Oh yeah.
He's got some tunes going back there. Hang on, let me find. I've changed the name of the parameters as I've gone here, so I think it's ports.
Yeah. And I have to drop this, guys. I'll watch the thing afterwards.
Oh, it's all good. Yeah, we're about to wrap up in the next 5 minutes. We're at the last couple of minutes. All right, so the host is gonna be the same thing. The ports is gonna be basically a range of ports. So I'm still scanning the same 3,000 ports. That the one that failed before because I had an unbounded concurrency problem. I'm just gonna leave the number of workers to the number of CPU cores. So in my case, it's gonna be about 8 workers or so doing their thing. So let me go full screen here. And if I'm lucky, if I did this right, that means that at no point will my program blow up, right? That means, the number of workers I have, it's in this worker pool, they are going to be, picking a work up from the channel where work is being fed to them. They're going to do the work, and when they're done, they're going to put that results back into our results channel. And then at the end, there we go. Here we are with our program didn't blow up this time, and what we did was we got ourselves the one port that was deemed to be open, which is 5432, and our program didn't blow up. We bounded the concurrency, right? We didn't let it go crazy, right? And we at any given time we had n number of Go routines that we know of that we were managing it, and we had a list of things that they were sort of going through. So the other examples are slightly more sophisticated versions of this worker pool pattern, like using things like semaphore and semaphore with timeout and context and things like that. But you get the basic idea is that, we've gone from a program that was scan this one hard-coded port to something that's parameterized, that we can go through a list of ports, to something that uses Go routines, and we see that we have to actually synchronize our Go routine access. And then we went to something that's a bit more sophisticated, that basically that did get through a list of work, but if the list arranges that we have to go through and the number of Go routines we have to launch is too big, right? Our operating system is going to step in and kind of shut up our program down, right? So to manage that, to mitigate that unbounded concurrency problem, we introduced the concept of the worker pool, which is limiting, and using channels and things like that, manages the number of Go routines that we have working on our things at any given time. Okay, so hopefully this was a whirlwind of a lot of things Go. I'm sure there's some things that don't quite make sense, or some things that worth exploring afterwards, but at least this gives you a pretty good idea of the power of Go, and something that you can definitely use to further your learning. We've been chatting for a while, and I'm gonna shut up for a little bit.
Yeah, are you gonna give away certificates? Like, I need a completion certificate to go search for jobs. Like some kind of expert certificate.
You do some, build some projects, man. Put that on GitHub.
Johnny, that was good, man.
That was really good. I'm really happy to, that I've been exposed to all that. It's really giving me more ideas.
Second thought, go fix that mistake you made.
Yeah, no, especially we're gonna be using containers and stuff like that. I just did a presentation last Wednesday because we've been building everything through doing a Debian file, and we have the deb repo, local and all this stuff, and now we're trying to make the switch to containers. So we some of us can do the Rust, but some of us probably will be doing the like me, I'll be doing the Go and stuff like that. I really like it because that's one aspect I like about Python, is to keep things simple. So I think that might be a better switch for us. in that aspect, because our first language is basically Python at work with the network guys.
Yeah, Go will be easy to transition to. You know, there's a lot of Python folks that have transitioned to Go or do both now. So you're gonna have a lot of resources out there. There's lots of from Go to Python blog posts and things like that. So
yeah, no, definitely. Well, so we can wrap up from this point, and I learned so much personally. Marconet, teaser code, what do you say? Switching?
I have no use for Go right now.
Yeah, you doing no?
I definitely want that certificate from Johnny, man, because you never know. I might get myself another job as Go expert developer at Google or Amazon. I don't know.
You still at Google, right?
Yeah, I am.
Yeah.
I was gonna say, I was gonna say, that was pretty good. These are the things that people pay good money to get exposed to. So we got it for free, and if you don't understand what's going on, it's okay, or even appreciate what we're talking about, it's okay. But as you get into creating more sophisticated program, these are the kind of things. These are the places where you see the value of Go, where you can create in your own code. You create something that can scale, tremendously, where you don't need something else. And I remember this distinct conversation I had with somebody from Java who has asked me about Go. She was like, well, where's the app server? Where's this? Where's that? Because I was telling her the program is all you need. That binary is all you need. You need nothing else.
That's a mental shift, yeah.
Right. It is a mental shift, especially if you're coming from Java, where you need an app server to do X and to scale your application for you. Whereas in Go, the program that Johnny had showed us, especially the last version with the worker and the worker pool, it is it. That is it. You could take that and scale it however you want. Obviously, as you need more scalability, you might have to tweak it a little bit, but that is it. So that's one of the things about Go, is that what you're building is what you'll end up using.
Right.
There's nothing else, and that's one of the things about Go. And once you build that binary, that's it. You don't need. There's most of the time you have no other dependency, and you can take that binary and push it through a different environment. I could sit here another hour and just expound on Go, but this was very good, and I'm glad I made time to come check out Johnny.
So Vlad, you also do Go at work? I don't know.
Yes.
Oh.
Yes, I do Go. I do Go at work, and been doing Go for since 2015, 16, maybe. Might be a little early. I don't remember. But before that, I was doing a lot of Java, and I got introduced in Go like around 2014, 2015. And it took me like a good year before I was like, hey, I'm all in, because I was a Java person. I was like, where's my exception? Where's my try and catch? Where are my where are my objects? I want objects.
Right.
But over time, I let to appreciate Go for what it is, which is a simplistic approach to representing your problem domain. And once I did that mental shift, I kind of accepted what Go is, and I have not looked back since, and I don't think I will. And once you start doing Go for a long time, the thing is, you refuse to go back to the ceremonious ways of doing things. Like in Java, for instance.
No problem.
Right. In Java, before you can even get to a solution, you have to think objects, relationship between objects, how the objects relate to each other, etc., etc.
Yeah.
Right.
I was gonna ask you that, guys. Like, 'cause I didn't see anything looking like objects in this program right now.
Yes.
It's kind of like
right.
a little bit.
Right. So there's no such thing as objects. I mean, you can do object oriented things, but there are no classes, I should say. Actually, that's a better description. There are no classes. Coming from a Java background back in the day, I was like, where are my classes? I need to create objects because that's the only way I can represent things. But it turns out that is not true. You don't have to start from a classical representation of the world. You can start from a functional representation of the world and still get things done.
Yeah, that's what I was gonna ask. I was gonna ask you, how do you create your instances if you don't have classes?
Yeah,
right.
Kind of the same idea in Rust, where you actually you do your struts and then you can actually implement it, and then that's where your methods actually go. Almost like the same idea with C. You have your header files and blah 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 and all this stuff, but so much simpler.
Right.
And
so much simpler.
Go is even simpler than that. It's a mental shift.
It is a mental shift.
I'm not there yet. That's the switch I need to make.
I mean, it's a mental shift, and a lot of people, they don't. Matter of fact, this whole week I've been having this conversation on Twitter with this guy from doing C#, right? And it's like, where's this? Where's that? Where's X, Y, and Z? Well, it's not there. It's just not there. Granted that if you're doing Go, in certain aspect, you're going to have to do a little bit of legwork for representation of data, for expression, etc. But I have learned to accept that because I know what I get. For instance, a very perfect example, like Johnny was saying with the error handling. When you make a function call or a method call in Go, a lot of time that method will return you an error, whereas in other languages, the exceptional state of your program can be encapsulated in something like an exception. In Go, you have to get to that. The function call directly will return you what the state or the it is what the normalcy of that call is.
Yeah.
And it is up to you to say, okay, I'm okay with it, or okay, I'm not. And it took me a long time to accept that because I was used to exception. I was used to the runtime blowing up in my face and then catching that later on.
Yeah.
In Go, it's like, no, instead of waiting for the world to blow up or even waiting to handle what happened, you can handle it right then and there. And I didn't notice that, through Go, I was programming completely different. Because of that, my code and the way I think about things has changed, because now when I make a function call or when I make a method call, I'm always thinking, okay, did that succeed? And if it didn't, what can I do about it?
Right.
Whereas if you're in a different language, like like a Node or Java or even Python, you don't have that. You could just throw things over the wall and hopefully right. And hopefully you have something that'll catch it.
Right.
It's a completely different mental model.
Yeah. No, totally. PJ Mix, you were gonna say something? Welcome back.
Yep, not much. I wouldn't say much, but I agree with Vladimir, which is all about making sure that if you write something, what happened in case that it doesn't work, and this is all going to be impacting the end user experience instead of them wondering like, did I go through? Did my transaction go out? Did you charge my card? Or what happened? Did I log in? Did I sign up? What happened? I think that's also good, just to make sure that we got better error handling. And of course, again, Jean Boursiquot, thanks for that presentation. I think you clearly demoed some interesting things out, which thanks to you. People that are watching or people that are going to watch this, and they're gonna benefit a lot from this. So thanks. Hopefully we see you more time or more often on this live, and then maybe we can do it more often. So that's good as to you guys.
Vlad Houston fait live yo man. Vlad monsieur just commencé Kubernetes là et puis il va Kounya la machine là avec Kubernetes en tête man.
No, man, we could finish it up. But anyway, I also want to thank Johnny. This was great. This is awesome. I learned a lot. I came in thinking, hey, let me see what Johnny was going to talk about, and he took it to another level. And like I said, what Johnny was talking about, people pay good money to get that, and we got it for free. So thank you, Johnny. Thank you for stopping by and doing your thing, man.
Yo, Johnny on buy qu'on abdormi la fait go man. Monsieur, yo, faut voir comme si j'aime Charlie rapide avec parce que nous we learn a lot from in so little time. So monsieur vraiment comme ça la fait. Malheureusement, je vais avoir l'école. So.
Monsieur Taneo.
But Johnny, I mean, Johnny was being modest. He is a Go superstar, and I was that when I said he's a legend, I was being truthful. So that's why I made sure that I came by to check him out. Being in the Go community, I know what his worth is, and people who follow Go understand what he's all about. So this was awesome, and we've hung out, we've talked, probably not enough, but he's a rock star in the Go community. So definitely this was great for us to have him.
Amazing. Thank you. Johnny, you came by, and I definitely learned like so many different aspects of the concurrency. I can't even say the word because I was just thinking about it in one aspect, and in just like those few minutes, I see so many different ways I can actually do things. I appreciate it so much.
So, avant monsieur dire quelque chose ça va dire et qui le drop tourner voilà
monsieur Gonda let's laugh
ouais bah là ça
nous pas dans
c'est ça que bon problème Vlad but I make him problème Johnny so
you want Johnny to come back? Johnny, you tell us, man.
I'm on the Slack. Next time, y'all have a slot open, just hit me up, and Randall and I will do what we did last time. Found a good time, and then and if y'all have specific topics related to Go that you want to cover, like very specific things, I can prepare something, or I can bring some other goodie, something else in my goodie bag. So either way, I'm good. Yeah, happy to.
Yep.
Awesome. Mais ok, so nous quitter le peuple. nous parler PG Mix, je dis PG Mix qu'on dit. Et à la prochaine, l'autre samedi.
Merci
Bye,
beaucoup.
everybody.